Germany delivered its refusal. For 25 years, Poland built its own god of war. 1989 forever redrew the map of Europe. Polish generals grasped this seismic shift before most. The Warsaw Pact, a monolithic alliance, began to fracture, then crumble. Soviet tanks, once the iron fist of Eastern Bloc power, rumbled eastward, leaving behind a void. With them vanished an entire ecosystem of weaponry, the very foundation upon which Poland's defense had rested for nearly half a century. A quiet panic settled within the hushed corridors of Polish military headquarters. Hundreds of Soviet-designed vehicles, once symbols of strength, now became liabilities. Spare parts, ammunition, maintenance protocols, every single component tethered Warsaw inextricably to Moscow. Yet, Polish leadership had already turned its gaze westward, towards the flickering lights of NATO, a new constellation of strategic alignment. Polish military engineers received a mandate that would make any designer's head spin. They were to forge a self-propelled artillery system, a 155mm howitzer, fully compatible with the exacting standards of the North Atlantic Alliance. On paper, the directive seemed straightforward. In practice, it demanded a complete regenesis. Soviet artillery had standardized on 152mm shells. Poland's entire industrial complex, its factories, its supply chains, its very expertise, was calibrated to this specific, now obsolete, dimension. The task was monumental. Factories required retooling. Engineers needed retraining. A machine had to emerge, capable of standing shoulder to shoulder with the formidable artillery systems of Germany, Britain, and the United States. Poland's initial logical move was to approach Germany. Berlin had engineered one of the world's most advanced self-propelled howitzers, the Panzerhaubitze 2000. Acquiring a license to produce it seemed the most direct path. The German machine was an engineering marvel, a testament to precision and power. It could unleash 3 shells in a blistering 9 seconds, striking targets over 30 kilometers away with devastating accuracy. Polish military officials were prepared to pay, to invest heavily in this proven technology. But Berlin's answer was a stark, unequivocal no. The official explanations were vague, deliberately opaque, but the underlying message was brutally clear. Germany harbored no desire to share its cutting-edge military technology with a former member of the Warsaw Pact, regardless of Poland's fervent aspirations to join NATO. This rejection became the defining moment. Polish generals made a decision that would dictate the project's fate for the next 2.5 decades. If no one would sell them a complete, ready-made system, then Poland would assemble its own. They would scour the globe for the finest components, then fuse them into a singular, potent entity. Thus, the concept was born, one later dubbed by military experts as the artillery Frankenstein. The ambition was audacious. Procure the best turret, the best chassis, the best barrel, and meld them into a cohesive whole. It looked brilliant on paper. The path to realization, however, was strewn with obstacles no one in the early 90s could have possibly foreseen. In 1997, the Polish Ministry of Defense announced an international tender for a turret system for their prospective self-propelled howitzer. Serious contenders emerged, including, with a chilling irony, the very same German Panzerhaubitze 2000. A high-stakes competition narrowed to 2 contenders, cutting-edge South African designs and the established British AS-90 system. London's BAE Systems ultimately prevailed, securing victory with its Braveheart turret. This was a battle-hardened component, already proven in the crucible of service with the British Army, widely regarded as a reliable workhorse. 1999 marked the signing of a pivotal contract. The agreement granted license for production, initiating a critical transfer of technology. This knowledge flowed directly to Huta Stalowa Wola, Poland's largest armaments factory, signifying a monumental step towards national defense self-sufficiency. The turret was secured. The next challenge loomed: a suitable chassis. Here, a powerful wave of national pride surged, dictating a distinctly Polish solution. The task fell to Obram, a company based in Gliwice. They were commissioned to develop an indigenous tracked platform. Engineers embarked on a path of adaptation, taking the Soviet MTS heavy artillery tractor as their foundation. This aging design would be modernized, integrating components from the PT-91 tank, itself a Polish iteration of the Soviet T-72. A complex lineage built on a foundation of decades-old foreign designs. The resulting chassis was designated UPG-NG. By 2001, the first prototype of what would become the Krab self-propelled howitzer rolled out. It was an imposing machine. The British Braveheart turret, crowned with its formidable 155mm long-barreled gun, towered over the Polish hull. The vision of a truly modern, domestically produced god of war seemed on the cusp of becoming reality. Initial trials were hailed as a resounding success. Military officials expressed satisfaction, and the press, in a flurry of patriotic fervor, lauded a breakthrough for the Polish defense industry. Yet, beneath the surface of this triumph, a silent, insidious threat was already taking root. It was precisely at this moment that the project began to unravel, nearly consigning the entire endeavor to the scrap heap of failed ambition. During rigorous, intensive testing, engineers uncovered a horrifying truth. Micro-cracks began to appear within the armored plates of the hull. Each concussive blast from the powerful howitzer generated vibrations that systematically degraded the chassis' structural integrity. This wasn't a minor flaw, it was a catastrophic design failure. The implications were stark, a death sentence for any combat vehicle. Even a minor shrapnel impact under these compromised conditions could cause the hull to simply rupture. A machine designed to operate under enemy fire, a machine meant to protect its crew, was inherently vulnerable, fatally flawed at its very core. A chill permeated the testing grounds. Simultaneously, another devastating blow landed. Poland's domestic industry, in a cruel twist of fate, announced the cessation of production for the very engine intended for the Krab. The project, once brimming with promise, now found itself in an impossible bind. The turret was ready, the formidable gun barrel stood tall, but the entire machine lacked the fundamental ability to move. The dream of self-reliance had become a nightmare of paralysis. Polish engineers faced a grim reality. Retreat was not an option. Millions of zlotys had already been poured into development. The British turret, a testament to international collaboration, sat waiting, a silent monument to a project that could not advance. The domestically produced chassis cracked under the strain, its fundamental structural integrity compromised. No amount of modification or reinforcement could overcome the inherent weakness. The Polish armored steel simply could not withstand the immense recoil of the 155mm weapon. For 13 agonizing years, the nation endured this torment, grappling with its flawed indigenous chassis. Finally, in 2014, Warsaw made an uncomfortable decision. It was an admission of defeat, a painful acknowledgement that the path of nationalistic self-sufficiency had led to a dead end. The search for an international partner began, a desperate plea for external expertise. The gaze turned to South Korea. By then, the nation had already established itself as a global leader, producing one of the world's finest self-propelled howitzers, the K-9 Thunder. The Korean machine was renowned for its unwavering reliability, having endured brutal testing in the unforgiving conditions of the Korean peninsula, where any mechanical failure could spell instant death for its crew. Samsung Techwin, later rebranded Hanwha Techwin, agreed to the unprecedented deal. In December of 2014, the foundations were laid for a stark new reality. What does it say about a nation's defense strategy when the pursuit of pride ultimately forces a surrender to foreign technology, after more than a decade of public expense and hidden failure? A contract was signed for the delivery of 120 chassis. Its terms reflected Poland's stark ambition. The first 24 platforms arrived fully assembled, direct from Korean factories. The remaining 96, however, were slated for assembly within Polish plants, under a meticulously negotiated license. This arrangement promised more than just a reliable mobile platform. It was a strategic gambit to absorb critical production technology, a calculated move to diminish future reliance on foreign suppliers. The deal's price tag hovered around $320 million. For the Polish military budget, this was a colossal sum, a commitment that weighed heavily on national resources. The Korean chassis arrived paired with a formidable German MTU-881 engine, delivering a staggering 1,000 horsepower. This power plant could propel the 48-ton machine to a top speed of 67 kilometers per hour on paved roads, boasting an operational range of nearly 500 kilometers without refueling. Polish engineers did not merely replicate the Korean design, they meticulously enhanced it. They integrated a domestically produced hydro-pneumatic suspension system, allowing the massive vehicle to squat during firing, dramatically increasing stability. An auxiliary power unit was also added, ensuring the crew could operate the sophisticated electronics without the primary engine running, a subtle but critical detail for stealth and endurance. The chassis question, it seemed, had found its resolution. But then, the barrel. This component ignited a true industrial saga. Initial prototypes were fitted with original British barrels, scavenged from the AS-90 howitzer. This temporary solution quickly dissolved when the British abruptly ceased production. A frantic search began for an immediate replacement, a scramble against the clock. The choice fell upon Nexter Systems, a French company renowned for its artillery. French barrels appeared on the howitzers displayed at the 2011 Arms exhibition. A fragile sense of normalcy returned. Yet even this French solution proved transient, a stopgap measure in a larger, unfolding strategy. Parallel to the Korean chassis negotiations, the Polish government had secretly funneled significant investment into modernizing the barrel production facility at the Huta Stalowa Wola plant. The underlying concept was brutally simple. If Poland was to forge its own god of war, its primary weapon had to be its own. Between 2014 and 2016, the facility underwent a complete overhaul. State-of-the-art machinery was acquired, personnel rigorously trained. Finally, in 2019, the first serial production howitzers rolled out, armed with barrels of purely Polish manufacture, 52 calibers long. What did this seemingly abstract number signify? Caliber length is the ratio of the barrel's bore length to its diameter. A 52 caliber barrel with a diameter of 155 millimeters translated to over 8 meters of pure, hardened steel. Longer barrels mean higher muzzle velocity, which translates directly to greater range. This new Polish weapon could hurl a standard high-explosive fragmentation round over 30 kilometers. Specialized gas generator munitions stretched that reach to an astonishing 40 kilometers. The fire control system became another source of national pride. Developed by WB Electronics, the Topaz complex transformed these howitzers into truly modern combat machines, integrating every critical function. This intricate dance of international procurement and indigenous development, of temporary fixes and long-term ambition, reveals a deeper truth. What hidden costs, beyond the staggering financial figures, were truly paid in this relentless pursuit of military self-reliance? A ballistic computer, instantly calculating trajectory, accounts for wind, air temperature, and barrel wear. Its navigation system pinpoints the vehicle's coordinates with an accuracy of mere meters, a precision absolutely critical for modern artillery. The commander receives target data through secure digital channels, firing within seconds of stopping. The speed of transition from travel to combat readiness is particularly chilling. The Krab requires just 30 seconds to halt, deploy its targeting systems, and prepare to unleash fire. The reverse process takes precisely the same amount of time. For self-propelled artillery, this parameter is a matter of survival. After firing a few rounds, rapid relocation becomes paramount, before enemy counter-battery fire can pinpoint the position. Sustained rate of fire reaches 6 rounds per minute. In a rapid-fire assault, the Krab can launch 3 shells in a terrifying 10 seconds. Its combat load consists of 40 rounds. 29 are stored within the turret for immediate access, while the remaining 11 are secured within the hull. 2 loaders operate manually, yet an automated feeding system significantly eases their brutal task. The 5-person crew includes the commander, gunner, 2 loaders, and the driver mechanic. The turret rotates a full 360 degrees at a swift 10 degrees per second, propelled by an electric drive. For close-quarters defense, a heavy machine gun, 12.7 millimeters in caliber, is mounted on the roof. This is a Polish adaptation of the formidable Soviet Utyos, rechambered for NATO ammunition. Smoke grenade launchers line the turret sides, ready to lay down a protective screen during withdrawal. The first production Krabs were ceremoniously delivered to the Polish Army in November 2016, during a formal event attended by the Minister of National Defense. 9 machines entered service immediately. Another 7 were in the final stages of acceptance trials. 25 years. That is how long Polish generals had pondered their own NATO-caliber howitzer. Finally, that ambition took steel form. The Artillery Training Center in Toruń became the initial home for these new self-propelled howitzers. 8 vehicles from the initial production series arrived here, used to develop tactical standards and train the very first crews. Polish artillerymen, long accustomed to Soviet systems, now grappled with an entirely different philosophy of engagement. NATO standards demanded a new mindset, a different coordination, and utterly distinct skills for operating advanced digital control systems. The 11th Masurian Artillery Regiment in Węgorzewo was designated to be the first combat unit fully equipped with Krabs. The location of this unit was no accident. Węgorzewo sits in northeastern Poland, a mere few dozen kilometers from the border with the Kaliningrad Oblast. What hidden pressures, what unspoken anxieties truly drove this quarter-century quest for a new gun, placing it so precisely at the edge of a new confrontation? Along the desolate, often forgotten borderlands, where the territories of Poland, Lithuania, and the isolated Russian exclave converged, lay a strategic choke point. This was the Suwałki Gap, a name whispered with dread in the war rooms of the North Atlantic Treaty Organization. For NATO strategists, it was not merely a geographical feature, it was a gaping wound, an exposed nerve on the alliance's eastern flank, universally acknowledged as its most vulnerable point. It was here, in this crucible of geopolitical tension, that Poland's new Krab self-propelled howitzers were destined to stand their first silent vigil. The ambitions of the Polish Ministry of Defense were monumental, etched in steel and fire. Their blueprint called for 5 artillery regiments, each armed with 24 of these formidable howitzers, totaling a staggering 120 machines. The 16th Pomeranian Mechanized Division, strategically deployed along the Baltic coast, was earmarked as the priority recipient. These elite units were tasked with safeguarding the vital approaches to Gdansk and Gdynia, the nation's largest ports, through which the very lifeline of Western Allied supplies would flow in the grim event of conflict. The Huta Stalowa Wola factory, a titan of Polish industry, was slowly, methodically scaling its production capacities. By December of 2016, the ink dried on a contract for an additional 96 machines, slated for delivery to the armed forces by 2024. The total cost of this rearmament program, an investment of unprecedented scale, ran into billions of zlotys. This marked the single largest financial commitment to Polish artillery since the nation reclaimed its independence in 1989. Each Krab, a marvel of modern engineering, carried a price tag of approximately $11.5 million. This figure was startling, particularly when juxtaposed against the significantly cheaper Soviet-era howitzers of the previous generation. Yet, the Polish military command was prepared to pay. They justified the colossal expenditure with the promise of superior quality and, critically, seamless interoperability with their NATO allies. The ability to utilize unified ammunition, to exchange targeting data in real time with American, German, and British forces, and to operate under a single, cohesive tactical protocol was deemed worth every last cent. But the ammunition, the very lifeblood of these powerful machines, became a separate, agonizing headache. The daunting prospect of establishing domestic production for 155mm shells proved prohibitively expensive and fraught with risk. The Polish company Zomet, based in Nowa Dęba, initially offered its services. However, a cold, hard analysis of the projected costs led to a stark conclusion. Cooperation with foreign manufacturers was the only viable path. The lucrative contract for ammunition supply ultimately landed in the hands of the Slovak company ZVS Holding, an entity already possessing a proven track record in the production of NATO standard artillery shells. Poland retained only the manufacturing rights for the KZ-9084 model fuses, a small consolation in a landscape of critical dependency. Special emphasis was placed on high-precision munitions. The Krab was engineered from its inception to fire American-made Excalibur guided shells. These sophisticated projectiles, each valued at over $160,000, utilized satellite navigation for pinpoint accuracy, capable of striking targets over 50 kilometers away with a deviation of mere meters. A single Excalibur round possessed the destructive potential to neutralize an enemy command post or an entire artillery battery, a task that would historically demand a dozen or more conventional munitions. The Topaz fire control system further integrated the Krab into the formidable Regina battery module, a network designed for synchronized, devastating strikes. Yet as the billions flowed and the machines rolled off the assembly lines, a chilling question lingers. What vulnerabilities were inadvertently built into the very fabric of this modernization? A system so reliant on foreign hands for its most critical components. What happens when the supply chain falters or geopolitical tides shift, leaving a nation's most potent defense assets dependent on the goodwill of others? A single, unified network. That is the ambition. Multiple howitzers, each assigned a precise firing sector, each locked onto specific targets. The battlefield transformed into a digital grid where destruction is orchestrated with chilling efficiency. From a solitary console, a battery commander could coordinate the fire of every gun. Tasks distributed, priorities shifted, all in real time, dictated by the unfolding chaos of conflict. This isn't just command, it is absolute control, a singular mind guiding a multi-headed beast of war. The system, known as Krab, extends beyond the howitzers themselves. It encompasses command vehicles, built on modernized MTLB chassis, ammunition transporters, and dedicated repair and evacuation units. This is not merely a weapon, it is a self-contained ecosystem of sustained, rapid destruction, designed to operate independently, deep within enemy territory. Its tactical doctrine marks a radical departure from the Soviet-era methods of artillery support. Gone are the days of indiscriminate, area saturation bombardments. The Krab prioritizes surgical strikes, delivering pinpoint devastation, then vanishing before the enemy can even register the attack. The mandate is clear. Deploy, fire a volley of shells, and disappear. The crew operates under an unforgiving clock. 30 seconds to unlimber, 30 more to pack up and move. This relentless dance of fire and evasion renders the Krab an elusive phantom on the battlefield, a ghost that strikes and fades, leaving only craters and questions. The enemy's frustration is a calculated byproduct. Polish engineers and the military strategists behind them took particular pride in the multiple round simultaneous impact, or MRSI mode. Its principle is simple, yet devastating. The howitzer fires 3 shells in rapid succession, each on a different trajectory. The first target at precisely the same moment. The result is not a staggered series of explosions, allowing for cover or escape. It is a single cataclysmic hammer blow. 3 impacts simultaneously. 3 chances for survival, reduced to 0. The target receives an unavoidable, unforgiving strike, a testament to the cold logic of modern ballistics. International exercises became the proving ground for this new technology. Krabs routinely participated in NATO maneuvers across Poland and neighboring nations. Artillery crews meticulously honed their coordination with Alliance air power, with unmanned reconnaissance drones, and with sophisticated counter-battery systems. Each exercise revealed new capabilities, new vulnerabilities, which the engineers at Huta Stalowa Wola relentlessly addressed, refining the weapon with every iteration. By 2022, the Polish Army possessed 72 Krab units out of a planned 120. Production rates suggested the program would meet its deadline, though some experts quietly voiced concerns over potential delays in the delivery of the South Korean chassis, the very foundation of the Krab's mobility. A hidden vulnerability, a fragile backbone of power. Despite these whispers, the Krab had already solidified its status as a potent symbol of Polish military modernization. It was a tangible declaration that the nation could design and produce world-class weaponry, an assertion of its growing influence on the global stage. Military experts worldwide scrutinized the Polish howitzer's specifications, comparing it against the market's established titans. Germany's PZH-2000, a system once rejected by Berlin, now stood alongside the Krab in NATO arsenals. The South Korean K9 Thunder, whose chassis formed the very core of the Polish machine, was exported to dozens of nations. France's wheeled Caesar set the benchmark for tactical mobility. Against this backdrop, the Krab had to justify its existence, not with rhetoric, but with raw, undeniable performance. Its primary strength, analysts concluded, lay in a chilling balance of characteristics. The Krab was not the absolute best in any single category, not the fastest, not the longest ranged, not the most heavily armored. Yet its integrated design, its networked capabilities, and its devastating MRSI mode combined into a package that was insidiously effective. A versatile instrument of destruction tailored for a complex, unforgiving battlefield. But what unseen compromises are made? What systemic dependencies are forged when a nation seeks to project such power? What silent costs are embedded within the very fabric of this advanced, interconnected war machine? The Krab, a self-propelled howitzer, emerged not as a pinnacle of innovation, but as a calculated compromise. It aimed for adequacy across all critical parameters, a machine designed to meet, not exceed, the demands of modern warfare. Its standard shell range extended 32 kilometers, a figure that placed it squarely among the majority of contemporary 155mm systems. This was not a benchmark of dominance, but rather a baseline of acceptable performance, a silent admission of its role as a workhorse, not a trailblazer. Firepower, a core metric, offered 6 rounds per minute. This fell short of the German PZH-2000's blistering 10, yet surpassed many other designs. Mobility on paved surfaces reached 60 kilometers per hour, a speed deemed sufficient for rapid deployment and tactical repositioning in a dynamic combat zone. These figures painted a picture of competence, but deeper scrutiny revealed unsettling truths. Direct comparisons with the formidable German PZH-2000 unveiled critical nuances. The German behemoth weighed 55 tons. The Krab, by contrast, registered a lighter 48. This 7-ton difference made the Krab significantly more adaptable for transit across bridges with limited load capacities, a crucial logistical advantage often overlooked in glossy brochures. Both systems shared an identical 1,000 horsepower engine. The Krab's lighter chassis, however, translated into a superior power-to-weight ratio, promising greater agility in demanding terrain. Its operational range, fueled for 480 kilometers, also edged out the PZH-2000's 420. These numerical differences might appear minor on paper, yet in the unforgiving crucible of actual combat, every single kilometer, every fraction of a ton, could dictate survival or destruction. At the heart of the Krab lay the British AS-90 turret, a component with its own storied yet troubled past. Critics consistently pointed to its genesis in the 1980s, arguing that the design was fundamentally antiquated, morally obsolete even at its inception. Polish military expert Krzysztof Wielewski issued a stark public warning. He declared that by 2025, a fundamental modernization of the turret section would be imperative. Without it, he argued, Huta Stalowa Wola, the very factory building these machines, risked losing its accumulated expertise, its skilled engineers, its qualified specialists. His words resonated as a chilling prophecy, a testament to a ticking clock. To rest on past laurels, he implied, would invite catastrophic failure. The Krab's armor offered a baseline of protection. It shielded the crew from small arms fire and the lethal fragmentation of artillery shells. Its frontal plating could withstand direct hits from 14.5mm rounds. The side armor provided defense against 7.62mm projectiles. Against modern anti-tank weaponry, however, this protection proved utterly futile. A direct strike from a high-explosive anti-tank, or HEAT, warhead guaranteed the machine's immediate incapacitation. The designers understood this grim reality. Self-propelled artillery was never intended for tank duels. Its defenses were calculated against different, less existential threats. The turret roof, however, remained its most glaring Achilles heel. Armor thickness across the upper hemisphere was minimal, leaving the machine critically exposed to attacks from above. In an era dominated by ubiquitous drones and precision loitering munitions, This vulnerability transformed from a design compromise into an existential threat. A single, well-placed strike from the sky could render the entire system inert. Engineers were acutely aware of this gaping flaw. Yet, increasing the roof's thickness would inevitably lead to a prohibitive increase in mass and a dangerous shift in the vehicle's center of gravity. The compromise solution involved the potential installation of additional protective screens. These, crucially, were not part of the standard factory configuration. Field operations exposed a harsh reality that glossy promotional materials conveniently omitted. On solid paved surfaces, the Krab performed precisely as advertised. But off-road, its speed plummeted to 30 kilometers per hour. Traversing severely broken terrain, riddled with bumps and ruts, the machine crawled at a mere 15 kilometers per hour. For an artillery system reliant on rapid displacement after firing, the critical shoot and scoot tactic designed to evade counter-battery fire, this crippling deceleration was not a minor inconvenience. It was a death sentence. How many crews, then, will pay the ultimate price for these calculated compromises? How many lives will be sacrificed at the altar of acceptable performance when the battlefield demands absolute superiority? The engine's cooling system became a critical liability. Designed for the temperate climate of Central Europe, the German MTU power plant consistently struggled under the scorching sun, succumbing to overheating during sustained, intensive operations. Mechanics reported the unavoidable necessity of frequent halts, forcing units to cool down their machines. This grim reality dramatically slashed overall mobility during critical maneuvers, transforming rapid advances into agonizing, vulnerable crawls. The Krab's electronics presented a labyrinthine complex, demanding an elite tier of specialized maintenance. Its TAPAS fire control system, a marvel of modern engineering, comprised a multitude of intricate modules. Each one required relentless, precise diagnostics and meticulous calibration. In the brutal, unforgiving conditions of the field, repairing these hypersensitive components proved virtually impossible. A damaged machine, even with minor electronic faults, became an inert monument to its own complexity, condemned to a costly, time-consuming evacuation to the rear. For an army forged on the rugged, unforgiving simplicity of Soviet-era hardware, this technological sophistication presented an existential challenge. The gun barrel, the very heart of its destructive power, possessed a finite lifespan, rated for several thousand rounds before replacement became mandatory. Yet, under the relentless, high-tempo demands of combat, this wear accelerated dramatically. The actual operational life often plummeted far below stated specifications. Prolonged, continuous firing caused the barrel to overheat, a physical distortion that directly compromised accuracy. Experienced commanders, acutely aware of this inherent flaw, meticulously managed their fire regimes, interspersing intense salvos with agonizing pauses, allowing the metal to cool. This constant vigilance, a silent admission of the system's limitation, dictated the rhythm of battle. A separate, insidious problem emerged: the logistical nightmare of its supply chain. The Krab consumed ammunition, fuel, and spare parts sourced from a bewildering array of international partners. Its shells arrived from Slovakia. Critical chassis components journeyed from South Korea. Sophisticated electronics flowed from Polish manufacturers. The formidable barrel group itself was forged in a factory in Stalowa Wola. Coordinating this global mosaic of deliveries demanded nothing short of flawless, almost clairvoyant logistical precision from rear echelon services. In times of peace, this intricate dance might appear manageable, but experts whispered a chilling question. How would such a fragile, multinational apparatus endure the brutal, unpredictable chaos of a real conflict? The answer remained horrifyingly unclear. The very existence of the Krab's production line hinged entirely on this delicate international cooperation. A rupture in relations with even one key component supplier could instantly paralyze the output of new machines, leaving assembly lines silent and strategic plans in tatters. South Korea provided the foundational chassis. Germany supplied the powerful engines. British technological prowess underpinned the design of its formidable turret. Poland, while proudly claiming final assembly on its soil, faced increasingly vocal critics who highlighted the profound systemic vulnerability inherent in such a fragmented, interdependent model. Polish designers, however, refused to be deterred by these inconvenient truths. The Krab platform, despite its documented limitations, was envisioned as the genesis for an entire family of combat vehicles. In August of 2023, the Polish Armaments Group Consortium announced the initiation of work on a heavy infantry fighting vehicle, to be built upon the existing artillery chassis. The concept, while not entirely novel, carried a certain strategic logic. Leveraging a proven, albeit problematic, running gear for diverse applications promised significant savings in development costs and a greater degree of fleet commonality. The first of these new machines were optimistically slated for delivery to frontline units by 2025. Then, September of 2022 brought a fresh surge of demand. The Polish Ministry of Defense inked a new, substantial contract, committing to the acquisition of an additional 48 Krab systems. A significant investment, doubling down on a platform whose inherent weaknesses were already well documented. What unspoken compromises were made in these procurement decisions? What systemic vulnerabilities persist, unaddressed, as these complex, interdependent machines roll off the assembly lines and into the hands of those who must stake their lives on their performance? $797 million. That was the initial price tag for a tranche of Krab self-propelled howitzers, a sum meant to replenish arsenals. These funds were to guarantee years of operation for the factory nestled in Stalowa Wola. Production lines churned around the clock, 3 shifts deep, as management aggressively recruited new specialists. A year later, the ambition escalated. A far more expansive framework agreement materialized. By 2023, the Polish government had sanctioned the acquisition of an additional 150 self-propelled howitzers. This contract alone commanded a staggering $2.5 billion, cementing the Krab program's status as the largest artillery project in the annals of modern Poland. Such procurement volumes signaled Warsaw's unwavering resolve to forge its military into one of Europe's most formidable forces. The aspirations of the Polish military leadership extended far beyond merely equipping its troops. This was about constructing a potent artillery fist, capable of executing operational-scale objectives. Imagine multiple artillery brigades, fully provisioned with these advanced self-propelled howitzers. They could secure overwhelming fire superiority across any segment of a potential theater of operations. The Krab transcended its role as a mere weapon. It became an instrument of grand strategy. The modernization of existing machines proceeded in parallel with the fabrication of new units. 8 early Krabs, mounted on the older Polish UPG-NG chassis, were slated for a radical overhaul. They would receive new Korean running gear. These machines, survivors of a tumultuous development period, were granted a second chance at full operational service. Engineers also planned comprehensive electronics upgrades and the integration of advanced communication systems. The international arms market observed Poland's howitzer with a peculiar interest. Delegations from various nations toured the Stalowa Wola plant, meticulously reviewing documentation and witnessing live-fire demonstrations. Yet, prior to 2022, not a single export contract ever materialized. The self-propelled artillery market remained a brutal arena. Germany aggressively pushed its Panzerhaubitze, South Korea actively exported the K9, and France successfully marketed its Caesar across the globe. Polish military strategists relentlessly sought avenues to amplify their artillery's combat capabilities. Negotiations with the Italian Leonardo concern focused on integrating Vulcano-guided projectiles into the Krab howitzers. These specialized munitions employed a sophisticated combination of satellite navigation and semi-active laser guidance. This allowed them to engage moving targets at ranges exceeding 70 kilometers. Extensive field trials were scheduled to validate the system's seamless compatibility. Crew training, too, underwent a significant transformation. The Artillery Training Center in Torun received state-of-the-art simulators. These virtual environments allowed crews to meticulously rehearse every aspect of combat operations without expending costly live ammunition. The implications of such simulated warfare, perfected without a single shot fired, remain unsettling. What does this unprecedented investment, this relentless pursuit of advanced firepower, truly signify for the delicate balance of power in Europe? What unseen pressures, what unspoken fears compel a nation to commit billions to an artillery program of this magnitude? Simulators replicated tactical scenarios, from infantry fire support to counter-battery engagements against superior forces. Young artillery crews honed their skills, their hands learning the intricate controls long before touching a live machine. Interoperability with unmanned systems became a critical development priority. The Polish Army acquired reconnaissance drones, instruments designed to pinpoint targets and relay precise coordinates directly to firing positions. The time from enemy detection to strike initiation compressed, shrinking to mere minutes. The Krab, with its rapid deployment capability, integrated seamlessly into this doctrine of network-centric warfare. Early operational experience exposed vulnerabilities. Engineers relentlessly refined electronic components, simplified maintenance protocols, and extended the lifespan of critical subassemblies. Every vehicle returning from exercises underwent meticulous inspection. All detected flaws were meticulously documented, feeding into a cycle of continuous, brutal analysis. The Huta Stalowa Wola plant transformed into a nexus of self-propelled artillery expertise. Unique technologies for barrel manufacturing, turret assembly, and electronics integration converged here. Losing these competencies, the engineers knew, would mean a catastrophic rollback of decades. Plant leadership, therefore, prioritized rigorous personnel training and the precise transfer of knowledge to a new generation. 25 years of relentless labor, of setbacks and unyielding persistence transformed an ambitious blueprint into a stark reality. The Krab evolved from a concept sketch on a drafting board to a serial production vehicle, now operational within one of NATO's largest armies. Germany's refusal to cooperate, once a perceived catastrophe in the 90s, ironically ignited the development of Poland's indigenous defense industry. Microfractures in one chassis forced a global search for partners. A triple shift in barrel suppliers forged a hardened engineering collective. Now, Poland's God of War stands sentinel on the alliance's eastern flank. It remains poised, ready at any moment to unleash hundreds of 155mm shells upon an adversary. What other critical dependencies, forged through decades of struggle and geopolitical maneuvering, lie hidden within the foundations of national defense? What price does true military self-sufficiency demand, and who ultimately pays it?